5 Toyotas you can buy this month with 250,000 miles already showing, drive for another 10 years, and hand off to somebody else still running. That's the list, and you're getting the year ranges, the money, and the one part on each that actually ends it. Not a slideshow of pretty trucks, the mechanical reason each one survives, and the specific failure that finally puts it down. I've had the head off a 22R that had done over 300,000 miles, and you could still see the factory crosshatch in the bores. I've also had the head off a modern Turbo 4 with 60,000 on it that looked like somebody took a rasp to the cylinder walls. That gap is not luck, and it's not brand loyalty. It's a set of engineering decisions made in the 80s and 90s that nobody would sign off on today. And once you know what they were, you can spot them on any lot in the country. Here's the thing that surprises people. On every vehicle in this list, the engine is almost never what kills it. Something else does. And on 2 of the 5, the thing that kills it is a decision somebody made in an office, priced in fractions of a cent per unit, that arrived at your door 15 years later as a repair bill. 3 flags before we start. Number 2 is the cheapest thing on this list by a wide margin and the one nobody wants, which is exactly why it's here. Number 4 is a car whose engine program alone reportedly ate around $400 million and something like 900 prototype engines. And you can buy one now for less than a decent used mower. And number 5 is the one where Toyota agreed to buy trucks back at 1.5 times book value regardless of mileage or condition. And the engine had absolutely nothing to do with it. Let's get into what they all have in common first, because that's the part that lets you judge a vehicle I haven't mentioned. Every one of these was designed around a duty cycle, not a warranty period. Cast iron blocks, low output for the displacement, timing components you can reach without pulling the engine, no direct injection, no turbo, no 10-speed automatic hunting for gears. Modest ambitions, executed with enormous care. You want the proof of concept, it exists, and Toyota paid for the teardown themselves. A Louisiana man named Victor Shepard put over 1 million miles on a 2007 Tundra with a 4.7-liter V8, crossed the million mark in 2016, maintained it with regular service using Toyota parts, and never replaced the engine or the transmission. Toyota swapped him a new 2016 Tundra Limited just to get the old truck back, because to their engineers, a million-mile truck was worth more as data than as a used vehicle. Months into the teardown, their own analysts were still saying the thing looked like a 100,000-mile truck. When the team in Huntsville pulled that V8 apart, it would have scored 99 out of 100 on their internal quality tests. And how did he do it? He changed the oil once a month, which for him worked out to roughly 10,000 miles. That's it. That's the whole trick. Which tells you something uncomfortable about how much of a vehicle's lifespan is actually in your hands, and how much of it was decided before you ever saw it. Number 1. The 1984 to 1995 Toyota pickup with a 2.4-liter 4. This is the foundation of the entire reputation. The fuel-injected 22RE made 116 horsepower at 4,800 RPM and 140 pound-feet at 2,900 in the 1985 to 1988 years, then got choked back to somewhere between 103 and 112 as emissions rules tightened, and the carbureted version made 97 to 103. Those are lawn equipment numbers by modern standards. That's the point. Here's the specific decision that matters. Every one of these engines left the factory with a forged steel crankshaft, not cast, properly forged, with full hardness and fatigue properties. And forged cranks shrug off the cyclic loading of high mileage running without developing the microscopic surface cracks that eventually finish off a cast crank. Forging costs more. It costs more per unit forever. On a truck sold on price. Somebody argued for it and won, And you are still collecting on that argument 40 years later. Nobody wins that argument now. With regular maintenance, these routinely run 350,000 to 400,000 miles. Plenty of owners report original blocks past 500,000, and the reasons are the iron block, the soft rings, and the sheer simplicity. You'll also hear it called the million-mile engine. I want to be straight with you about that. The 500,000 and million-mile stories live on forums and in dealership folklore, and I've never seen one properly documented with receipts. Treat them as plausible rather than proven. 400,000, I'll defend all day. What end's won, not the bottom end. On a well-kept 22RE, the common high-mileage items are the timing chain, which stretches around 150,000 miles, the head gasket after an overheat, and the lower timing chain guide. By the way, if you drive a Toyota and want to keep it running for hundreds of thousands of miles, what you do before something breaks matters far more than most owners realize. That's why I put together the 500K Mile Car Care Bible. It covers 101 habits that can help your Toyota last longer, the warning signs you should never ignore, and how to spot mechanic upsells that quietly drain your wallet. To get your copy, just scan the QR code on screen with your phone's camera, or grab it from the first pinned comment below. And none of those are catastrophic. Each gets handled during normal service. The chain guide is the one to understand, because it's the one that turns a cheap job into a dead engine if you ignore it. The guides are plastic. They wear, the chain goes slack, and a slack chain starts sawing at whatever is in front of it. Owners who've been through it fit metal guides and stop thinking about it. The tell is a rattle on cold start that fades once oil pressure comes up. Cold start rattle that fades usually means worn plastic guides. Plan for the job. Don't tell yourself it's a lifter. 2 more things and we move on. If you're shopping, the 4-cylinder is the one you want. The 3.0-liter V6 of that era had a head gasket problem serious enough that Toyota ran a special service campaign over it. And on a carbureted truck, if there's no evidence the carb has ever been rebuilt, assume it needs one and budget $200 to $400 for a proper job. The W56 5-speed manual is robust. The 4-speed automatic is fine, but can get lazy about shifting in a high-mileage truck. Money. Clean examples on the classic listings start around $8,000, and a rust-free 4-wheel drive with a straight bed costs real money now, because everybody figured this out at the same time. Which brings us to the exact opposite. From the truck everyone wants, to the car nobody does. Number 2, the 1992 to 2001 Camry with the 2.2-liter 4. Short section, on purpose, because there is very little to say, and that's the entire recommendation. The 5S FE will run hundreds of thousands of miles on less than perfect maintenance. 2 things to know. It's a timing belt engine, 90,000 miles, and the job runs roughly $320 to $570. And the known weak spot isn't in the engine, it's the oil pump seal. One owner had it let go at around 160,000 miles, which dumps oil fast if you're not watching. That same car got sold at 190,000 not because the engine was tired, but because of rust. And the rear cross member is where you look. A 120,000 mile example was sitting on a lot recently asking $4,500. That's the whole pitch. It's boring. It's dull to drive, and it will outlive your interest in it. Now step back for a second, because a pattern has shown up twice already, and it holds for the rest of the list. Notice that on both of those, I told you about the engine in one paragraph, and then spent the rest of the time on rust and on a rubber or plastic part. That's not an accident of how I write. That's the actual hierarchy of risk on a well-designed vehicle. The iron outlasts everything, and the failure migrates outward to gaskets, hoses, seals, and structure. From here, the money goes up, and so does the engineering ambition. The next three were built with budgets and design targets that no volume manufacturer would approve today. And I have not forgotten number 5, where Toyota ended up writing checks measured in billions over the thing the engine was bolted to. Number 3, the 1993 to 1997 Land Cruiser, the 80 series, with the 4.5-liter 6. This is a 4.5-liter 24-valve twin-cam straight 6 that replaced the older F-Series engines, brought smoother running to the Land Cruiser without giving up any Toyota durability, and was built with a cast iron block, a timing chain, and deliberately conservative output. Endurance rather than efficiency, which made it the favorite of overlanders who needed hundreds of thousands of miles with nothing opened up. In North America, it made 212 horsepower and 275 pound-feet through a 4-speed automatic. The chain has no replacement interval at all. Here's the evidence, and it's the best evidence on this whole list, because somebody took one apart on camera. A tear-down channel got hold of a 1FZ from a 1994 Land Cruiser with 343,000 miles. It came out of a truck wrecked badly enough that the engine arrived non-running, and testing showed low compression in 2 cylinders, a perfect candidate to see what actually goes wrong. What they found, no metal shavings or fragments anywhere, which he pointed out you can't say about far newer Toyotas. Camshafts, cam journals, and caps with only the minor wear you'd expect on any engine, never mind one past 340,000. A timing chain still in good tension with a tensioner that didn't look worn, and all 24 valves clean with barely any buildup. Clean intake ports, evenly worn plugs, some varnish and sludge under the valve cover. And now the honest part, because I'm not here to sell you a truck. The same man who tore it down finished by saying that despite its fame among Land Cruiser people, the 1FZ isn't actually as reliable as some other Toyota engines of that era, because the head gaskets will fail on even slight overheating. That's real. The original gasket design was prone to leaking between coolant passages. Any overheating event dramatically accelerates it, and the symptoms are white smoke on cold start, coolant disappearing with no external leak, and an oily film in the coolant. I've read the community argue for years about whether it was the gasket material or something more fundamental in the deck, and I'll be honest, I've never seen Toyota explain it publicly. So anything I told you about the root cause would be me guessing with confidence I haven't earned. What makes it worse is a detail I love and hate in equal measure. The factory temperature gauge on these is center biased, which let a lot of owners run near or over the line without the needle telling them anything. Think about what that means. The gauge was designed to keep you calm on an engine whose one real weakness is heat. The rest of the ownership picture, quickly, because these are the numbers that decide whether you can afford one. There's a short heater hose, about 4 inches long, tucked at the left rear corner of the cylinder head underneath the intake plumbing, that owners named the pesky heater hose. Decades of heat cycling kill it, and the parts are $50 to $400. It can let go with no warning, and the failure can cost you a warped head, 4 inches of rubber. Replace it before it decides for you. Toyota specifies repacking the front axle burr fields and knuckles roughly every 90,000 miles, $300 to $1,500, and the radiator has plastic end tanks crimped to an aluminum core that go brittle and crack, usually near the boss on the top tank, $300 to $800. Rust is what actually kills these. Moderate rust on an 80 series, floor sections, lower quarters, lower doors. Runs $6,000 to $14,000 at a shop that does it properly. And once the frame is involved, it's a different conversation entirely. Money, and brace yourself. The average sale price across the 80 series is about $27,000 and a bit over $28,000 for the ones with this engine. A clean landed example can still be had for around $20,000. The buying rule that matters most. Skip anything under $15,000 unless the paperwork is complete, because a cheap Land Cruiser is deferred maintenance and rust. And what you saved goes twice over into the frame and the cooling system. Factory front and rear lockers add roughly $2,000 in value and are worth hunting for. You're still with me, which tells me you're either shopping or you already own one of these. 2 left, and if you take nothing else from this, take that $15,000 rule and apply it to every vehicle on the list at its own price level. The cheap one is never the cheap one. If this is the kind of thing you want more of, subscribe and you'll get it. Next up is the one I flagged at the start, the $400 million engine you can now buy for beater money, and the reason it exists at all is a memo somebody wrote in 1983. Number 4. The 1990 to 2000 Lexus LS 400 with the 4.0-liter V8. Toyota's second production V8 came out of a secret project called F1 started in 1983. Nothing to do with racing, it stood for Flagship Number 1, and the goal was a luxury sedan that could beat the best from BMW, Mercedes, and Cadillac head-to-head. They did not approach it the way you'd expect a car company to. The project ran through 1,400 engineers, 2,300 technicians, and 60 designers, 450 prototypes, half a decade, and about $1 billion. Roughly $400 million of that went on the engine alone, with 900 prototypes built. Sources don't agree on that count. One puts it at 973 prototype engines. And they disagree harder on test distance. Some say over 1.67 million miles of real-world testing. Others claim 3 million miles, including flat-out running on the Autobahn. I'll take the lower number because that's what more than one source supports, and because 1.67 million miles is already an absurd figure for a single model program. Here's the detail that tells you what kind of people were working on this. They used lightweight aluminum cam followers to hold smoothness at high revs, cut the machining tolerances on all moving parts by up to 50%, and tested parts to destruction under accelerated aging. Cutting tolerances in half is not a performance decision. Tight tolerances are how you get an engine that doesn't wear. Every thousandth of slop you remove at the factory is wear that never accumulates over 300,000 miles. The brief was that a Lexus with 50,000 miles should feel no different to drive than a new one. And to get there, the engineers studied how paint, plastics, rubber, and upholstery aged, along with wear, vibration, squeaks, and rattles. The result made 250 horsepower and was so smooth that one of the ads built a pyramid of crystal glasses on the engine while it was running. And the durability is not a myth. The LS400 made Consumer Reports' list of vehicles capable of over 200,000 miles back in 2007, and plenty of careful owners have since recorded 3 times that. A version of this engine was even approved by the FAA for aircraft use in 1997, turbocharged at 360 horsepower. Now the reality of buying one. The whole game is the timing belt, and the sources give a range. One specialist puts it at 105,000 miles with the water pump done at the same time. A general estimator says these belts typically get done between 60 and 100,000. I do it at 90 and stop thinking about it. Belt and pump runs about $750 at normal shop rates, and a full job at a dealer level rate lands closer to $1,000 to $1,350. One important wrinkle from the owner community: 1995 was the first year the engine became an interference design, meaning a snapped belt on a later car can bend valves rather than just leaving you sitting. That's community knowledge rather than something I can point to in a factory document, so treat it as a reason to be conservative on any of them. Budget mentally for the starter too, because it's a considerable amount of work to get at. And the price. Typical used examples run $3,000 to $8,000, with genuinely well-kept low-mileage cars reaching about $10,000. $1 billion engineering program. An engine developed with 900 prototypes for the price of a decent trailer. There is no rational market explanation for that. It's just that nobody wants a 30-year-old luxury sedan, and depreciation doesn't care how many engineers you hired. Last one, and this is where the story turns. Number 5. The 1996 to 2004 Tacoma and the 1996 to 2002 4Runner with a 3.4-liter V6. The 5VZ FE made 183 to 190 horsepower and 217 to 220 pound-feet depending on year and application, built around a forged crankshaft and sintered connecting rods. These routinely cross 300,000 miles. And they do it with exactly one non-negotiable demand: a fresh timing belt on schedule. Toyota calls for that belt every 90,000 miles or 7 to 10 years, whichever lands first, because rubber ages whether you drive or not. A 15-year-old belt with 40,000 miles on it is still a liability. The good news is it's a non-interference design, so a snapped belt shouldn't crash the valves into the pistons. It'll just stop the engine instantly, which is its own kind of dangerous. Do the water pump, the hydraulic tensioner, and the idler pulleys at the same time, as a kit, because they're all in there, and it's the same labor. It's a real weekend job for an experienced home mechanic and a routine one for any independent shop. The other things to know are small. The knock sensors sit under the intake plenum and eventually fail from age, throwing a light and pulling timing. And while the sensors themselves aren't expensive, the wire harness that runs to them gets brittle and is usually the actual culprit. The lower intake gaskets weep coolant on high mileage examples. The distributor on the earlier cars can develop a shaft bearing rattle. None of that is an engine problem. All of it is the periphery aging around an engine that isn't. And that is exactly the point of putting this one last, because the 5VZ is not what ended these trucks. Something else did, and it was not a wear item, not neglect, and not a design compromise anybody made to hit a price. Here is what you were told. You were told, for years, that a Toyota body-on-frame truck was the safest used purchase in North America, that the frame under it was the reason the whole thing was overbuilt, the reason it held up under loads, the reason it was worth the premium over the domestic competition. That was the sales argument. That was the reputation. And on the trucks built for the North American market across roughly 1995 to 2004, the frames rusted through from the inside out. Not surface corrosion, perforation. Frames that separated. Spare tires that dropped out of the carrier because the crossmember holding them dissolved. Trucks where you could put a screwdriver through the rail beside the leaf spring hanger. Now, the mechanism, because the mechanism is the accusation. A boxed frame rail is a sealed tube. Whatever protection goes inside, it goes in once at the factory and can never be reapplied by you. The rails on these took on road salt and moisture through drain holes and seams, held it against bare steel, and corroded from the cavity outward. which means by the time you can see it from underneath, the section is already gone. There's no inspecting your way out of it and no maintaining your way out of it. The decision about whether your truck survived 15 winters was made before it left the assembly line by whoever specified what went inside that tube, and you were never in the room. Toyota's own response tells you they knew exactly what they had. They ran a frame inspection and replacement program. They agreed, on the earlier trucks, to buy vehicles back at 1.5 times Kelley Blue Book value, regardless of mileage or condition. A figure I want you to sit with, because a manufacturer does not pay above book value for a used truck it has no obligation to buy. That is what a company pays to make something go away. Then in 2016 came a settlement covering roughly 1.5 million Tacomas, Tundras, and Sequoias, with an estimated value in the region of $3 billion, running inspections and frame replacements out to 12 years from first sale. $3 billion on the part of the truck that had nothing to do with the engine. And notice what the remedy actually was. Not a redesign you could retrofit. Not a coating you could apply. An inspection window with an expiry date, after which the problem became yours entirely. If your truck perforated in year 13, you got a letter that no longer applied to you. The engine in it was good for another 150,000 miles, and the thing holding the engine up was scrap. Somebody had to sign off on where that line sat. 12 years, not 15, not life. And that line was drawn on a spreadsheet, not on a corrosion test. I don't think anybody set out to sell you a rotting truck. That's not how this works. What happens is that a corrosion protection spec is a cost line, and cost lines get reviewed, and somebody with good intentions and a target to hit found a number that passed the validation testing and saved money at volume. The testing was almost certainly honest. It just wasn't 15 years of Ontario road salt, because nothing tested in a lab ever is. So when you go and look at one of these, and the seller tells you the engine has never given a moment's trouble, believe him. He's telling the truth. Then get under it with a small hammer and tap the rails from the cab back, past the spring hangers, around the spare carrier, and listen for the difference between a ring and a thud. That 5 minutes is worth more than the entire service history sitting on the passenger seat. And now you know why. Which means that particular sentence, the one about the bulletproof frame, doesn't work on you anymore. Here's what I keep coming back to. Every vehicle on this list is a case of somebody choosing the more expensive thing when they didn't have to. A forged crank on a cheap pickup. Machining tolerances cut in half on an engine nobody would ever open. A cast iron block in a decade when everyone was going thin and light. Those were arguments won inside companies, by engineers, against people holding cost sheets. And the reward for winning them arrives 30 years later, in somebody else's driveway, in a truck that still starts. That's a strange kind of gift. Nobody who made those decisions is going to get thanked for them. The engineer who insisted on the forged crank in 1983 retired long before the trucks he was arguing about hit 400,000 miles. And the same is true in reverse. Nobody gets blamed for the frame spec either. Decisions made by people who'll never meet you show up as your Saturday morning, your bill, your good luck, or your bad. All you can really do is learn to read which way the decision went on the vehicle in front of you before you hand over the money. That's the whole skill. Everything else is just details. So, the list. The 1984 to 1995 pickup with the 22RE, forged crank, iron block, Watch the timing chain guides and the carb on early cars, and buy the 4-cylinder over the V6, around $8,000 and up for a clean one. The 1992 to 2001 Camry with the 5S FE, timing belt every $90,000. Watch the oil pump seal and the rear cross member, and around $4,500 buys a good one. The 80 series Land Cruiser with the 1FZ FE, magnificent engine, weak head gaskets, and a temperature gauge that lies to you. Do the 4-inch heater hose before it does you, and don't touch one under $15,000. The LS 400 with the 1UZ FE, a $1 billion program for beater money, timing belt and water pump at $90,000, and treat any of them as if bent valves are on the table. And the Tacoma and 4Runner with the 3.4, belt every $90,000 or 10 years, whichever comes first, kit with the pump and pulleys, and the frame decides everything. Here's the procedure I'd actually run on any of them. Before you look at a single car, find out what a frame or body repair costs at a proper shop in your area, and what a timing belt and water pump costs at an independent. 2 phone calls. Then look at the asking price and add both numbers to it, assuming neither has been done. If that total is still a car you want to own, go and see it. If it isn't, walk, no matter how good the engine sounds. Because the engine was never the question on any vehicle in this list. Run that on your own numbers, and you'll never buy a bad one. Do that, and here's what happens. Nothing. For years. You'll change the oil, you'll do a belt on schedule, and there'll be a stretch of 4 or 5 years where the only thing you spend on that vehicle is fuel and tires. That absence is the payoff. It doesn't feel like anything. It's just a bill that never arrives. Now I want to hear from the people who think I got one wrong. Specifically, the Land Cruiser crowd, because I said the 1FZ isn't as reliable as its reputation, and somebody out there has a 400,000 mile 80 series on original gaskets and is already typing. Bring it. Tell me the mileage. Tell me the climate. Tell me whether it's ever been over the line on the gauge. And if you've had a frame replaced under that program, I especially want to know what the truck looked like when you took it in, and whether the engine was still healthy at the time, because I suspect it almost always was, and I'd like to know if I'm right about that. I read the replies on these, all of them, and the corrections are usually the most useful thing on the page. So, don't be polite about it. Subscribe if you want more of this kind of thing. I've got a growing list of engines that everybody says are indestructible, and I'm not convinced about half of them. And there's one very famous diesel I keep almost covering and then backing away from because every time I dig into it, the story gets messier. I'll get to it eventually. Until then, check the frame before the engine, do the belt before it asks, and drive it like you plan to keep it.